So, if you've been building anything with large language models, like Claude, you know that feeling, right? That little jolt of excitement when you spin up a prototype and it just works. It really does feel like you've captured lightning in a bottle. But then, reality sets in. How do you take that cool demo, that little bit of magic, and turn it into a real product that people can depend on?
And that's the big question, isn't it? It's the one that developers and tech leaders are all grappling with right now. We see these mind-blowing demos pop up on social media every single day. But actually getting that same level of performance to work reliably, at scale, inside a real messy business environment, well, that's a whole different ballgame. Let's really dig into why.
You know, the gap between a demo and a production system is just massive. A demo is all about having fun. It can be fragile, it can be a one-trick pony, and that's okay. But a production app, it has to be reliable. It needs to be scalable. It has to be woven into everything else. I think the best way to put it is this. Building a demo is kind of like building a shed in your backyard. You can probably knock it out yourself in a weekend. But building a production AI system, that's like building a skyscraper. You need a proper blueprint, a deep understanding of your materials, and a totally new kind of engineering mindset. You need an architect. So how do you go from being a shed builder to a skyscraper architect? Where's the blueprint for this new role? Well, it's actually starting to take shape, and we found a really amazing guide for it in a place you might not expect. Anthropic just put out this exam guide for something called a Claude Certified Architect, and when you start reading it, you realize pretty quickly this is way more than just a list of facts to memorize for a test. It's basically a framework. It lays out in incredible detail what it actually takes to build these big, robust, production-ready AI systems. This is the skyscraper blueprint we've been looking for. So what's inside this blueprint? Well, the guide breaks this whole discipline down into 5 main pillars of mastery. These are really the foundational skills that separate the weekend tinkerer from the professional AI architect.
And here they are. You can see how it all breaks down. We've got stuff you'd expect, right? Prompt engineering and Claude Code workflows, both taking up about 1/5 of the pie. Then you've got tool design at 18% and context and reliability at 15%. But look at that biggest slice. Taking up a huge 27% is something called agentic architecture. That right there, that's clearly the cornerstone of this whole thing.
So what on earth is agentic architecture? Well, it's really the art and science of building systems where the AI isn't just passively answering a question. It's about designing a system where the AI can actually reason on its own, come up with a plan, and then use tools to get things done. We're talking about a shift from a simple Q&A bot to an autonomous agent that can actually accomplish complex, multi-step goals for you.
And this is basically how that agent thinks. It's called the agentic loop. It all starts when your application sends a request to Claude. Claude might think for a second and then say, hey, to answer this, I need to use the lookup order status tool. Your system sees that, goes and runs the tool, gets a result, and then feeds that new information back to Claude. And the loop just keeps going. The AI is constantly reasoning, taking an action, and then reasoning again with new information until the job is done. But of course, it's not just about that loop. That's only one piece of the puzzle. Looking at the other pillars, you see that a real architect has to be a master of the whole ecosystem. You're the one designing the actual tools the AI gets to use. You're integrating it into coding workflows. You're engineering prompts that are rock solid and reliable, not just clever. And you're managing the entire system to make sure it's robust and doesn't fall over.
Okay, so theory is one thing, but what makes this guide so valuable is how it grounds all these ideas in real-world business problems. So let's check out how all this stuff actually gets applied in practice.
Okay, let's start with this scenario I think pretty much every company on the planet is thinking about right now. Building an AI agent to handle customer support. This is a perfect stress test for an AI architect's skills. But just look at how complex this gets. We're not talking about a simple FAQ bot here. This agent has to understand fuzzy, ambiguous requests from users. It needs to use tools to connect to real-deal backend systems to look up an order or even process a refund. And this part is so important, it needs to know its own limits. It has to be smart enough to decide, you know what, I can't solve this. I need to get a human. And the business goal is an 80% resolution rate on the first try. That is a serious engineering lift that pulls from every single one of those 5 pillars.
All right, now for something even more advanced. Let's look at a different scenario where the job isn't just to build one AI agent, but to architect a whole team of AIs that all have to work together.
This is such a cool example of what that agentic architecture really means. It's about orchestration. So you have a coordinator agent who's basically the project manager. It gets a big research task, breaks it down into smaller pieces, and then delegates those pieces to a team of specialists. You've got a search subagent that hits the web, an analysis agent that reads through documents, and a synthesis agent that pulls it all together into a final report. The architect's job here is designing that entire workflow, how they talk to each other, how work gets passed along. It's incredible.
So when you put all of this together, the 5 pillars, the complexity of these real-world scenarios, it becomes really, really clear what's happening. We are literally watching the birth of a brand new engineering discipline. And this is not something you just pick up overnight. The guide itself recommends you have at least 6 months of real, hands-on experience before you even think about trying to get certified. And that really drives home a key point. Being an AI architect is a role that's defined by deep, practical experience. It's not about what you've read, it's about what you've built, what you've seen break, and what you've learned from fixing it. This quote from the guide just sums it all up perfectly. A real architect doesn't just get excited about what the AI can do, they have a deep, almost instinctual understanding of what it can't do. True mastery is knowing those limitations and building safe, reliable systems that account for them, with all the right error handling and escape hatches to bring a human into the loop when you need one. And that kind of leaves us with this one big, fascinating question. Remember when cloud computing became the new infrastructure? A whole new role, the cloud architect, became essential. Well, the same thing is happening right now with AI. As these models become a fundamental layer of our tech stack, just like a database or a network, does that mean we all, in some way, need to start thinking like AI architects? I think that's a question we're all going to be answering very soon.